Alright guys, here is your next note. So again, I'm just gonna go and I'm gonna explain, as you can see, the characteristics or the key features of quadratics. So what each one means. And yeah, so I think, again, when this stuff comes into word problems, it's gonna make a lot more sense. But anyways, let's just get through it. Let's get started. So a quadratic relation in graph form, it is U-shaped and it is called a parabola. So we went over that last note, okay? So it's this U-shaped guy right here, right? This is a parabola, it's not a straight line. So it represented in the form, it is represented, apologies, I should fix that, in the form y is equal to ax squared plus bx plus c. Okay, so if you guys remember from a couple of notes ago, now I'm trying to think of the exact one, but I can't remember. I apologize. We had a name for that. Do you remember what that name was? It was standard form. Standard form. Okay. So hopefully you remember that. Gosh, makes sense. Okay. So for an example, we can have so many different things, okay? It could be y is equal to x squared plus 2x. Let's throw a negative in there somewhere, minus 4. Okay? Just an example. And what we would do is that we would take this graph and we would, or this equation, we would graph it. And we need to find out different things about it, which I'm going to go through, but also too, you guys would have to factor this. Okay, so the two things that add to that number but multiply to that number. Again, I don't know. I just threw in a random equation. I don't know if you guys would be able to factor that. I don't think you can actually. Not with the method I taught you anyways. So, a reminder, there is an x squared in the term for a quadratic relation. So, I'm going to make that a bit bigger. So, which of the following is a quadratic relation? So, y is equal to x squared. Is that quadratic? Yeah, because, I'll lighten that up. Because it's y is equal to x squared. Y is equal to 2x plus 4. Is that one? No. Right? It is not one because there's no squared, right? Could you tell me what type of graph this is? It's linear. Okay, that's just a little fun side thing. Y is equal to 3x. Is that quadratic? Nope. Because this has a 1, so this is linear. Y is equal to x cubed minus x squared. This actually isn't one due to this. Okay, that's a cubic function. You guys, I don't think you ever go into that, but it's the same idea. It's just use a cube instead of a 3 or 2. Y is equal to 2 to the power x. No, that's not one. That's exponential. Again, something else you guys don't do. Y is equal to 9x squared plus 3x minus 1. Yes, okay. Like what we were doing before, this is definitely 1 because of the x squared. I know it also has an x in it, but it's x to the 1, so it's okay. Y is equal to negative x squared plus 7x minus 1. Yes, that is 1 because same idea. It has an x squared in it, and the other x that's with it is to the power of 1. Again, this one is 1 as well. Okay? So, those are different examples. And then, which of the following is a parabola? So, hopefully you guys could look at this. No, that's linear. The first one, that's not one. That is... I want to say that one. No, that's not exponential. I can't think of what that one is. Oh, well. Forget what that one's called. There's my parabola right there. Whoop. and that guy is something else. So yeah, that's what parabola is. Where will you see parabolas in the world? Now I want you to think about this for a sec. Where would you see that curve? Okay, and now you don't have to think of it as going down, right? Because it's going to be a little harder for us. If we think of it as another, like a parabola that goes like this, it might be easier for you to think about it. So different things that would look like that would be like a water fountain. It could be a bridge, like the structure under the bridge to help support it. It could be satellite dishes. Okay. Like, I don't know if any of you guys, I don't know if they even have them anymore. Those, like, old Bell, like, if you had satellite TV, you had to have a dish on the side of your house. I don't think you need that anymore, but... many other ones when a ball's being thrown. Oh, forgot the H. Okay, many different examples, okay? So, let's get into it. So, the vertex, we did talk about it last note. So, the vertex is, there's a couple of different ways of looking at it, okay? So, it's the maximum or minimum. So it depending on the way the direction is with respect to our parabola. So a quadratic has a maximum or minimum value at the vertex. So the vertex is called the turning point. So it means when the graph, the line on the graph is going a different direction. Okay. So the vertex can be like at the top of a mountain, like it is here, or the bottom of a valley, which it is more so like this. Okay. So if you think about this too, with the top of the mountain, the max point, well, that's the highest point it could possibly go. So that's why this is called our max. Where if we're down here, like in our valley, it's the lowest point that it could actually go. So that's why we say our max or our min. Okay? So vertex can be at the top of the mountain when the curve opens down. Okay, so as you can see down, it's going down like this. So that's why it has a maximum. Or if it's opening up like it is here, it has a minimum. It has a bottom point. So you're going to be asked a question, what is the maximum value of this graph? Or what is the minimum value? So that's pretty much what I'm going to be giving you on your quiz on Friday, is you're going to get a graph and you're going to have to tell me all these different features. So what I think I'm going to do is I'll give you the graph for a question, and then I'll make you guys graph one, but you can just like use Desmos. Like, I'm not worried about that. Okay? So, let's take a look at this first one here. So for this example, what would be my vertex? What is the point of which things start to change direction? Well, as you can see, this is the highest possible point before it starts changing directions. So what's my x? My x is 2, and my y is 3. So my vertex is 2, 3. And that's all you'd have to tell me for the vertex. And then, does it have a max or min value? Well, because the curve opens down for our first one, it has a max value. So I'm going to write max. And what's the highest point that it reaches to? Well, that has to deal, our maximum has to deal with our y axes. Because if you look at our x, the x kind of continues forever. So what's the highest point? So if I were to grab my ruler, if I were to look at it like this, what's the highest point that my line or my parabola reaches? Well, as you can see, it's 3. Okay, so my max value is 3. That's the highest point. Okay, think of y to the sky. Y is our height. Usually represents height. What else was I going to say? I was going to say something else about this. Now I can't remember. Yeah. Okay, so that's our vertex. One thing maybe that you guys pointed out, maybe you realized, our vertex are 3 for our, because this is my y value, and this are the same. Okay, same. Look at that. Ooh, I'm going to get rid of that. And I'm going to get rid of those lines. Da, da. Okay, so the next one, my vertex. What is my vertex? What is the point in which my parabola starts changing directions? Well, again, okay, as you can see, it's down here. We do x, y. So my x, I go all the way over 1. Or sorry, here's -2, so it's every other one. 1, 2, 3. And what's my y value? -3. Okay, so that's the lowest possible point, or that's the vertex. That's when my parabola starts changing direction. Okay, so what's my max min value? So what is the lowest or highest possible point on this graph? Well, where did my ruler go? There it is. Same idea. We can see that the parabola is opening up. So because it's opening up, as you can see here, it has a min point. So we know it's min, so I'm going to write in min. If you don't tell me it's max or min, you're going to lose a mark. Again, what's the lowest possible point that it reaches? We're using our y-axis. -3. And remember, those 2 points are going to be the same. Okay, that's your vertex. You do have practice questions, so I'll be going through one with you, and then I'm going to give you guys a chance for your turn, and then your practice questions are these questions over and over and over again, okay? Okay, direction of opening. Oh, super easy. The sign in front of the x squared determines whether the curve goes up or down, okay? So, if it's negative, the curve goes down. Okay. So remember, down goes like this. That means we have a maximum. So this is now starting to roll together. Okay. Sorry, I'm just playing around. So, if the sign out front is negative, we have a maximum. And as you can see, the direction of opening, in this case, is down. If it's positive, it opens up. As you can see, this guy's also opening up. So, little side note. Let's get a side note color. I don't know. There's like limited choices, like of actually decent colors. Use that ugly green. We use that light blue. We use that kind of blue. Okay, so if we have x squared, a positive x squared, we know that the curve opens down and that means, oh, I lied too. If we have a positive, the curve opens up, and that means we have a minimum. So this is just like a little summary. Might have to add more to it after. Where if we have a negative x squared, okay, that means this, here's our Cartesian plane, it goes like that. Negative x squared goes like this. That means the curve opens down. And that means we have a maximum. It's always going to be the case. Okay, that's why I'm doing that. It's always going to be like that. Just little rough notes. Let's see if we can add to it after. Okay, the x-intercepts, the zeros. This is where the parabola crosses the x-intercept. Or the x-axis, sorry. So there could be 0, 1, or 2. That's it. So this is, how do we figure this out? By factoring. Okay, so when we factor, which I've taught you guys how to do, this is what we find is our x-intercepts. And again, when we do word problems, you're going to see why we do this. So if I were to look at my first one here, what are my x-intercepts? Remember, this is my x. Where does it cross the x line? Well, it crosses at, this is 1, and this is 3. Right? Because this is half, 1, 1.5, 2, 2.5, 3. You got to watch the units on those axes, guys. Okay? So, what is my x-intercept? We have 1, 0, and we have 3, 0. Okay? Remember xy, xy, xy. Okay, let's look at our next one. What's my x-intercept? There's only 1, and that's okay. That means the vertex is on our x-intercept, or our x-axis. So that number is -3, so it's -3, 0. So this one has 2 zeros, this one has 1 0. How many does our last one have? It doesn't have any. There's none. Because if you can see, here's our x-intercept, and the parabola doesn't even cross it. And that's okay. That's going to happen. And that's all right. Okay? So that's what our x-intercept does. How do we find our x-intercepts? We factor it. Okay? Y-intercept, you guys know this one too. Okay, we did it with y is equal to mx plus b. It's when it crosses the y-axis. So it's that point right there. So at the y-intercept, x is equal to 0. You guys know this. Oh my god, we've done this so many times. Okay. So in this case, what's my y-intercept? You gotta look at the spacing. That's a half, that's 1, that's 1.5, that's 2. So it's -1. 0, -1. This does play a role, okay? You guys will see it. Let's look over here. What's my y-intercept? It's 2. So 0, 2. I guess that's all I have to say about that one. Okay, axis of symmetry. A quadratic relation is symmetrical, meaning a mirror image is created. So when you go back up to our vertex, okay, we were looking at the point of which it were to switch directions. All of the parabolas of which we're going to, well, all parabolas are, that we're going to deal with are mirror images of each other. So if I were to grab a mirror and place it exactly on my axis of symmetry, the parabola would look the exact same in the mirror as it would on my sheet. If I were to move it over here, they would not look the exact same. It would look like a W. Okay? This is the point where they would look the exact same on the mirror and on the paper. So, a quadratic relation is symmetrical, which means a mirror image is created. So that means this is the axis of symmetry. That's this guy right here. I know I did that really thick. Okay, let's do that again. Oh my goodness, I know. It's that guy right there. Okay? That is my axis of symmetry. That is where the point turns. So the axis of symmetry always passes through the vertex. So it is expressed as x is equal to what? So this has to deal with our x value. So where on our x line, so right here, does our parabola change direction? Well, it changes at 2. So all we're doing is x is equal to 2. Okay? Over here, where's our axis of symmetry? It's that guy right there. I know I'm not exactly on it, but you get the point. What point is that? It's -3. That's when it changes directions. Okay? Again, we also talked about our vertex, like I did up here. Okay? All the way to the top. Oh my goodness. My dog just walked in. It scared me. The vertex is that point where it changes direction, right? Well, oops. If I were to look at my vertex at this guy, it would be -3 and 2. Actually, let's do this. Because we did it in blue, so let's keep it in blue. -3, 2. We'll take a look. Meow. Hi. What are you chewing? What are you eating? Oh, it's gone now, isn't it? Of course. So as you can see, the axis of symmetry is whatever the x value is in my vertex. Okay. So now we're going to get into an example. So one last thing I'm going to add to here is for our vertex, I might not have the exact same color, I apologize, is x, y, right? That's always a coordinate for us. It's always x, y. The x value is our axes of symmetry. So when I say what's the axis of symmetry, it's the x value of our vertex. Our y value is our max or min. So whatever our max or min is, you can look at the y value of our vertex. Now, this might seem like, oh my gosh, a little overwhelming. That's okay, guys. We're going to be doing examples. Hopefully it'll come together. If it doesn't, just know these other basics. Just like know all these different rules for when it comes to you guys having to do your questions. Okay? Okay, so let's do the example. And then I will get you guys to do the last one. And if you want me to check it, I can. Actually, you know what I'll do? I'll just put the answer in for you. And you guys can take the time to go through it. I won't explain it. Okay? So, label and state the vertex x, y. So, vertex x, y. Vertex is this point right here. So it's 2, 4. Because that is my vertex right there. Then, state the minimum or maximum or minimum. Well, hopefully right away you can look at it. And because it's opening down, right? It's opening down. That's just common sense. The very top of it is our maximum. And what's the highest point? So again, if I got my ruler, what's the highest point that this parabola reaches? Well, it's 4. And remember, those two are the same. What did okay, whatever. I'm just going to go in order. Label and state the zeros. Okay, the zeros mean where it crosses the x-intercept. There's one. It's okay that it's at 0. And there's another one. So, what are my x-intercepts? They are 0, 0, and 4, 0. 0, 0. And 4, 0. Label and state the y-intercept. Okay, my y-intercept's actually right here too. That happens. And it's 0. That's just a coincidence. It happens, and that's okay. It's just wherever it crosses the y-intercept. State the direction of opening. Down. And state the axis of symmetry. Okay, remember it's x is equal to, and it is 2. Right? It's when it starts, when it's exactly a mirror of each other. When it's exactly a mirror of each other. Or it's our vertex. Okay? I hope that makes sense, guys. There's lots of practice questions, 1, 2, 3, 4, 5, 6, 7 for you. You can also go through this next one to practice it. I'm just going to throw in the answers, okay? And then if you're not sure where I got them, look through the note, and then hopefully that'll make a bit more sense. Sorry, I'm really spaced out because... state and label the zeros. The zeros are... Okay, there's that. Do your practice questions, and you will be getting your quiz on this on Friday. Okay, guys, enjoy the rest of your day.